All right, thanks, Erica. Well, thanks everybody for joining today. I think we have an interesting topic today. We'll be doing a comparison of the Azure SQL database and the Azure SQL data warehouse. My name is Bob Rubocki. I am a consultant with Pragmatic Works. You can contact me after the session if you have any questions or you just want to ask me a question about business intelligence, data warehousing in general. Feel free to reach out to me. My information is there. And the reason this was a topic I was looking forward to talking about is we get a lot of questions. We do talks about the Azure SQL database. We do talks about the Azure SQL data warehouse. And there are a lot of questions out there about, well, what's the difference between them? So that's what our focus is going to be today. We'll start off with a review of how they are similar, because they do share some things in common for sure. But we'll spend most of our time talking about how they're different, really focused on the data warehouse features and how they're different from the database features. And then sprinkled throughout, we'll talk about different use cases. How do I know if I should use the database or use the data warehouse? So we'll talk about that as we go, and then I've got some points at the end about that as well to kind of help you decide if you're trying to understand the difference between the two and which one to use. Beginning with the similarities, on the surface, they do have a lot in common. At the highest level, both the Azure SQL database and the data warehouse are part of the platform as a service architecture that Microsoft provides. They're both relational databases. So as you can see in my screenshot, I've just connected to an Azure SQL data warehouse and an Azure database through Management Studio. So you connect to them in Management Studio the same way. And if you're connected to them via an application or a report, the connection strings are the same. There's really no difference there. And so they both have the benefits of being on the platform as a service, which means that it's a fully managed database service in the cloud. Your data is stored multiple times for redundancy and protection. All of your backups and your security are all managed in the cloud. And both services give you the ability to scale up and scale down as needed. We'll talk more about what that means for the data warehouse, but they both have that ability to say, okay, well, during the day, maybe I have more activity, I will scale up the service, and maybe in the evening I have less, I'll scale it down. Or as my database grows, my needs change. Both platforms provide that ability to scale up, scale down. So what really starts to separate the Azure Data Warehouse is the Azure Data Warehouse is really designed to perform very well aggregate queries on large volumes of data. That's really what it's designed for. It's designed to perform well with star schemas and the dimensional models. So if you have one of those built, queries that use a star schema type join are designed to perform very well in the Azure SQL Data Warehouse. One really interesting thing I think about the Azure SQL Data Warehouse, is that it's really the next generation of what was the APS, or the Parallel Data Warehouse platform. Those tools are really powerful, but they do require specific hardware to be installed and configured. And it's really a really cool thing that now we can just go out to the Azure portal and provision a data warehouse really within a matter of just a couple seconds. You can use this technology that used to require specific hardware to be installed and a lot of time spent configuring all that. So this is a really, really powerful feature that's available in Azure. And I think for that reason, I think it's worth taking a look at just to play with it, to try it out, to see if you're curious about it. Any discussion of the differences between Azure SQL Data Warehouse and the database, I think, have to start with a discussion of massive parallel processing. So the Azure Data Warehouse is built with the massive parallel processing architecture. And that means a few things. The parallel part means that your data is stored in the cloud version. It's stored in 60 different distributions. And when you execute a query against the Azure SQL Data Warehouse, the control node that's illustrated on this diagram here will actually execute 60 separate queries on each of the distributions. And that's the parallel processing piece of that, is it's actually running those queries in parallel, and then it will combine those results and provide a single result. So if you're running the query from a client tool, the result is very much the same. It's a select statement, if you will, and it just returns a data set, just like a database query, but under the covers, it's doing this parallel processing. Another key feature of this is that the processing power and the compute power, the storage power they're separate. And we'll talk more about that in a second here. But your storage is really independent of the processing here. And that's what this diagram is illustrating. I've got the one control node with a number of compute nodes, and those compute nodes are then aligned with your data that's stored out in blob storage. And that's the final piece I wanted to mention about the architecture, is that with the Azure SQL Data Warehouse, your data under the covers is stored in Azure Blob storage. So this is a very quick overview of what the massive parallel processing architecture is. We're going to talk more a little bit later about how we configure that architecture when we're building our data warehouse. But for now, I just want everybody to understand that this is one of the key differences between the data warehouse platform and the database platform. When we're talking about scale of the database and the data warehouse, there's some terminology that we need to understand. When we're scaling and talking about the power of the Azure SQL database, that's measured in database transaction units, or DTUs. Whereas in the Azure SQL Data Warehouse, there's a similar concept, but it's known as a DWU, or a data warehouse unit. In both cases, these are what Microsoft refers to as a blended measure. It's a number that kind of gives a relative scale based on the amount of memory, CPU, and I/O resources that are dedicated at different levels of power. We'll talk more about what those are in a second. There's no real good way, though, to compare, to say, okay, this many DTUs in the database kind of correlates to this many DWUs in the warehouse. So I don't really try to draw a comparison there. But in both cases, the higher the DTU or DWU level, the more resources will be dedicated to your process. So that's true in both cases. Now, I said that the value of DTUs and DWUs in and of itself doesn't really mean anything. You can't really correlate that to a specific server spec per se. But one thing that the DWU level does indicate to us is how many compute nodes are dedicated to your process. So at the most basic level, you get one compute node, and that one compute node then controls the processing of those 60 distributions. But as you scale up your data warehouse, you'll get more of those compute nodes. When we are provisioning SQL databases, we have quite a few choices to make. So there are 3 levels of tiers in the database. Let me back up. I think it's at the warehouse. I'm going to start talking about the database. The database has tiers that are basic, standard, and premium. And so you've got 4 of them that are in the standard and 6 of them that are in the premium. The basic is a good way to get started, but not too many people really use that in production because it is what it says. And then on the right there, I've got the number of DTUs. And so the DTU levels go from 5 DTUs all the way up to 4,000. On the data warehouse, we've got, there are no tiers, which I think is important to realize and understand. We'll talk more about some of the differences between the tiers, but in the data warehouse tier, the only thing that we're controlling or scaling is the amount of compute power. So when we're talking about the database, the standard and the premium have different storage in some cases, et cetera, and it's a little bit more complicated to understand the differences. On the data warehouse, it's pretty simple. The only choice you have is how much power do I want to provide to my data warehouse. This is a key differentiator between the 2 platforms, is the database size limit. So I'm going to cut to the good stuff and talk about the Azure SQL Data Warehouse. There is no documented size limit for the size of your database. And the reason for that really is because the data is stored in Azure Blob Storage. And with Azure Blob Storage, we really have, I hesitate to say infinite, but vast scalability. If we're provisioning an Azure SQL database, we do have limits. And so the limits that I've posted here, there are some new service tiers that are in preview, but as of today, the tiers that are generally available, you have a maximum at the premium level of a 4 terabyte database. So if you're trying to start thinking about, well, is the data warehouse right for me? Certainly if you're operating a data warehouse on premise that is more than 4 terabytes, you're gonna, you could change that, but you're gonna struggle to get that to work in the database, and you'd probably be looking at the data warehouse. This is another differentiator or difference between the two, is the number of sessions and concurrent queries that are allowed. So on the Azure SQL Data Warehouse, at the highest level, you're only allowed to have 32 concurrent query executions, which depending upon what you're doing, that can be plenty or it can be a challenge. But when you compare that to the Azure SQL database, at the highest level, the Azure SQL database supports up to 6,400 concurrent queries. And if you think about the workload of the two types of databases, it kind of makes sense. In the Azure SQL Data Warehouse, you might be running fewer queries, but you are processing and reading massive amounts of data. Whereas in the database, if we're thinking about an application or an OLTP process, you may have many queries, but they each may only be referencing a small segment of data. So if you think about, if you log on to a website and pull up your order history, you may only have a few rows of order history, but you can have many thousands of people running that same query. But the style of data warehouse query is more, I've just got a handful of people that are querying and analyzing vast amounts of data. So, but I think it's an interesting difference to point out when we're talking about the difference between the database and the data warehouse. The way that backups are managed is a little bit different between the database and the data warehouse. Ultimately, the data warehouse does not take backups as frequently. So on the database, it's doing transaction log backups every 5 or 10 minutes is what the documentation says. And so if there's a failure, or if you need to roll back with the database, you can roll back to pretty specific points in time. The Azure Data Warehouse, the snapshots, it's a snapshot, and it's taken every 4 to 8 hours, depending upon availability of the service. And then those backups of the data warehouse are only maintained for a maximum of 7 days, whereas with the database, you can keep them for up to 35 days. That's available with the service. There are techniques for retaining them for longer, but that's outside the scope of the platform service. So let's get down to what this all really means, which is pricing. How much does it cost to run one of these? So there's a range. On the database, per month, and these prices were as of this morning. And again, these are just the prices of the tiers that are generally available as of today. They're working on some other tiers and pricing options, but this is what's available today. So for the database, you're going to pay anywhere from as little as $5 per month for a basic, all the way up to about $16,000 for the top-end premium database. So the pure dollars for the warehouse generally are going to be higher. So you see the range there from about $11.25 for your lowest end data warehouse, all the way up to $67.5 for the top end price. One big difference about how the pricing works with the data warehouse is you do have to pay for the data storage on top of the processing. So the $11.25 and $67.5 that I've listed there is just the cost of the compute resources. there is an additional charge of it's about $135 per terabyte per month of data storage. So by way of comparison, I just put references there on the bottom that when we're talking about the entry-level data warehouse of $1125, that roughly in price corresponds to somewhere between a P2 and a P4 database. And then on the over here on the low end of the data warehouse, oh, I'm sorry, I made a mistake in my comments there. But what I was trying to illustrate here is that this data warehouse 1200 for 13,000 is about the same price as the high end database, which is about 16,000. So if you think about just price-wise, the maximum database is about the same cost as a 1200 or 1500 DWU data warehouse. And on the low end of the Azure SQL Data Warehouse, you're talking about a comparable price of a P2 database. A really interesting feature that's available only with the data warehouse is the ability to pause the compute service when it's not needed. So if we think back to the connection limits, the intent of the data warehouse perhaps is that you have a smaller user base and maybe it's only used during business hours. Well, I can just pause the service altogether. And when the service is paused, I am not going to be billed for any charges for the service. Your data is still stored, so I'm still going to be charged for my data, but being able to turn the service off entirely when it's not being used is a good way to manage costs. The way that you can pause the service, there are a couple different ways. I've shown a screenshot here of the pause feature in the Azure portal interface. You can also do this through a PowerShell command. And if the database service, if the data warehouse service is paused and you try to connect to it, this is an error message that I pulled from SQL Management Studio. It'll tell you that, hey, you cannot connect to it because it's just turned off. It's just like the whole database is not available. So a little bit about the developer experience and how this differs between the warehouse and the database. If you've ever gone out to the Azure portal and you're looking at the properties of your data warehouse, you may have seen this button here that says Open it in Visual Studio. And when I saw that, I thought, oh, well, that's great. I can do my design of my data warehouse in Visual Studio. But the note below there is from Microsoft's documentation. And the note is saying that you cannot use database projects for Azure Data Warehouse. What the Visual Studio option there will do, you can open Visual Studio in the data tools or with SQL Server data tools, and you can use the object browser to look at the tables and the columns in your database. But to be clear, we cannot use database projects. Now, I will say I have used Visual Studio database projects for building my data or it's really more for managing it. I like to use it still for version control. You can organize your files in the same way you would a database project, but we just don't have the build and the deployment functionality available there. I understand that it is coming. And that's the note there at the end of the screenshot, is that they are working on this. But as of today, you cannot deploy or build your Azure SQL Data Warehouse with Visual Studio. It is important to understand that there are some differences in just SQL functionality between the database and the data warehouse. So what I have here is just a partial list of some of the features that are available in the database that are not available in Azure SQL Data Warehouse. So a couple things right off the bat: primary and foreign keys. There are no primary and foreign keys inside the Azure SQL Data Warehouse. One thing that is worth noting here, though, is up until recently, identity fields were not available. And so using identity fields is a pretty common pattern that people use for loading their dimensions. So use an identity field to create your surrogate key. But this only became available as of June 28th of this year. So I have the cross through that one. Identity fields are available in Azure SQL Data Warehouse. Those of you that have worked a little bit in Azure SQL Data Warehouse understand that there are some differences in just your SQL querying. Not so much in the select. The selects work just as you would expect. But if you're using a merge statement in the Azure SQL database, the merge statement is not available in the data warehouse. Also, if you're writing an update or a join, or I'm sorry, an update or a delete, using the ANSI join syntax is not supported. So if you're trying to port a query or stored procedure over to the data warehouse platform and you're using joins inside of updates and deletes, you'll have to rework those. And then this one I thought was interesting too. And this, I guess, is just a style thing. When I'm writing SQL and I'm setting the value of a variable, I might use syntax similar to what I've outlined in red, which is selecting the variable value is equal to some result from a query. That syntax does not work in the Azure Data Warehouse, so you've got to kind of switch that around and use the set like I've outlined there. So set your variable equal to the result of a query. So those are just some quick differences to be aware of if you're getting into using the Azure SQL Data Warehouse. We're going to talk now about kind of getting back to the massive parallel processing and the distributions and how do we create our tables and how is this different in the data warehouse than it is in the database. So the first thing that we need to understand is that when we're creating a table, we have to determine what's called the distribution method. And this is the method that's used to take the data from a table and to spread it or distribute it across those 60 distributions. And I want to emphasize the word distribution. I think that there's a tendency for people to kind of compare them to partitions. And while they are similar, they really behave and are used much, much differently. So we're talking about how do we distribute our data across those 60 nodes. And we have 3 different options for this distribution. The first one is round robin, which is just a sequential, the data is going to be evenly spread across the 60 distributions. The next one is the hash. So the best example I can think of on the hash would be if you have a fact table with maybe a product key, you would hash the fact table based on the product key so that all of the records for each product are stored on the same distribution. But each product then, or I'm sorry, the various products would be spread across the 60 distributions. I'll show an example in a second of what that looks like. Something that's also relatively new, and this was available as of just a few weeks ago, I believe. I don't have the exact date on this, but the ability to replicate a table to all distributions. This is something that was available in the APS and Parallel Data Warehouse platform. And the idea here is the best example I can think of is like a date dimension. In a lot of cases, it would be nice to have the entire date dimension. If I had, let's just say, 10 years of dates, I wouldn't really want to spread those dates across the individual distributions. The query, if we do that, the query will run and it'll run fine. But if the query had all of the date data available on its distribution, it would not have to go across distributions to get the date data. So with the replicate option, which again is new in the Azure Data Warehouse, we can store a copy of a table on each of the 60 distributions to hopefully improve performance. The other option that we have when we're creating a table is how is the data stored? And by default, Azure SQL Data Warehouse uses clustered column store index storage. If you're trying to decide between platforms, it's important to understand that the clustered column store index will really only provide a benefit when you can get 1 million records into a distribution. And once you have 1 million records, now is when, or at that point is when the clustered column store index will do the compression and actually store it in the column store storage. Until then, if you have fewer than 1 million records in your distribution, it can, in name, be stored as clustered column store, but in reality, it's not using that column store technology until you have 1 million records. So if you want to take full advantage of this, since we've got 60 distributions, any table that has more than 60 million records will be able to take full advantage of the clustered column store index. But if your tables have less than 60 million, you're really not going to be able to take advantage of the clustered column store performance benefit. So the other two options are heap. Heap is not as bad as it sounds in a lot of cases, but that is really, it's just like a heap in your on-premise SQL Server. It's a data table with no indexes. The other option is to use a clustered index storage. Yeah, so I touched on this a second ago, but this is kind of how I like to think of, okay, well, if I'm faced with this decision about how do I, or which method do I use for distribution, generally speaking, your fact tables are good candidates to be distributed using that column hash. So for example, we're going to walk through a demonstration of this in a second. If I've got a fact table and I'm doing a lot of queries that are breaking this down by, I want to know like my top 100 products. Well, in that case, it would be a good idea to consider hashing the product key on your fact table. So your fact table is spread across all 60 distributions, but the data for each product is stored on one distribution. Skipping over to the replicated, again, the idea of having a date dimension or some smaller dimension that could really help queries on individual distributions, I think are great candidates to be replicated. Whereas much larger dimensions, so I'm thinking about a large customer or product dimension where maybe you've got tens or hundreds of thousands of rows, would be better candidates to be distributed with the round robin. The reason that I would not suggest, the column hash for the dimensions is because your dimensions generally have unique values. So there's generally no good candidate field to hash on, because if you're thinking about a surrogate key value, you've got a dimension with 10,000 records. Well, you have 10,000 unique surrogate keys. So there's really no benefit to hashing them because you've only got one record. So it doesn't really matter which distribution it goes on. And if it doesn't matter, then round robin is a good option. So we'll walk through just a quick example of a query that you might have in your data warehouse and how you might design your tables in the Azure Data Warehouse. So here I've got a pretty simple query where I'm pulling data from my sales fact table, and I want to show my top 100 products, and I want to filter it for just this year. And maybe my fact table's got about 200 million records. My product table's got about 50,000 records, and my date dimension has about 10 years or 3,600 or some odd date records. The way that we tell Azure SQL Data Warehouse how to store it is, or how to distribute it, is with this distribution option. And if I can find my pen here, you have this option here for distribution. And so what I mentioned earlier is on my fact table, I generally want to hash on one of my foreign key fields. I should use that word more carefully. One of my dimension key fields, so that all of the values for one product are stored on the same distribution. So this is how I would create my table. It looks very similar to creating a table in Azure SQL Database or in your on-premise, but we have these options here for how do we store it, and then this distribution method here. And again, this clustered column store index, I selected this in the fact table because my table has many more than 60 million records. So with more than 60 million records, I will be able to take advantage of the clustered column store storage. And let me get rid of that. So now in my product table, again, I had about 50,000 records. I'm going to choose in this case just to spread them evenly, round robin style, across all 50 distributions. So this looks similar to the way I defined my fact table, except for my distribution is different here. I've selected round robin, and then here I'm using a clustered index based on the key, the product key for storage. I don't want to use the clustered column store here because I have way fewer than 60 million records, so there's really no real gain for me to use the clustered column store index. And I had another picture in there of my date table that wasn't appearing, but the date table in that case, I just used the replicated option, and that's, you would just put the word replicate here instead of round robin. A really nice feature of the data warehouse that's not available with the database is what's commonly referred to as CTAS. Everybody calls this CTAS, and it's this command that's called, it's create table as, is what that means. And where I think this is really handy is when you're building out your data warehouse and you're trying to test, well, which distribution method is best, which storage method is best. And if you were building an on-premise or using Azure SQL database, that decision of, okay, which key is going to be my cluster key and how am I going to store this can be a really time-consuming decision that takes a lot of thought and input. With the Azure Data Warehouse, using this create table as, it makes it really simple to try and use different storage techniques. So if I had my sales table here, and I was doing a lot of queries on the product dimension, and it was working great, using the distribution based on the product key is going to be just fine. But over time, if your use case changes and people are doing more customer analytics, for example, you may want to consider changing how that table is stored. And to do that, all we have to do is just, I'm in this example, creating a new, like a copy of the table, but using a different distribution. And this is generally a very fast operation, but it's going to take all of the metadata structure of the fields that I've selected here and create a copy of the table, but with a different distribution technique. And then with the data stored differently, I can test queries and see how they perform. But this CTAS functionality is unique to the Azure SQL Data Warehouse, and I think that it's really quite handy. I want to talk a little bit about Polybase. If you've read or played with Data Warehouse, you've probably come across the word Polybase. This is something that, whoops, and I found a typo there in my first line. Available with SQL Server 2016. It's now available in the Data Warehouse. It's not yet available in Azure SQL Database. I don't know if they're working on that, if that's on the roadmap, but if I was guessing, I would guess that at some point it would be available. But the idea with Polybase is that you can query data from unstructured sources, such as Azure Blob Storage. And this is a really powerful piece of functionality that's available in the data warehouse. And it's so powerful, in fact, Microsoft actually recommends using Polybase for your data warehouse loading because it can take full advantage of the parallel processing capabilities of the database. So what this might look like in your object browser, you've got a folder for external tables, and those external tables are Polybase. They look like regular tables, but when you query them, what you're actually querying is, in this case, an Azure Blob Storage location. You're querying, in this example here, a set of files. So your table can be linked to an individual file, or if you have a folder with a number of files that all have the same structure, I can point my external table to that folder, and I can query that data from all of those separate files, and the results look like just like I'm querying from a regular table. So talking a little bit about how I might use that in a pattern for loading my data warehouse. If we're using Polybase and external storage, the process of loading my data warehouse becomes more of an ELT process instead of an ETL process. And what this might look like would be following these steps, where I would take the data that I want to load my data warehouse and load that into blob storage. Then I can take the data from blob storage, and using Polybase, I can query that data stored in blob storage and put it into an actual table, perhaps a staging table in my data warehouse. And now once I have that data staged, I can now do my transform. I can either do this with T-SQL, or if I've done a lot of the transform already ahead of time, now is where I could take advantage of partition switching if I've partitioned my data. But that's just one option for using Polybase to get data into your data warehouse, and a sample of a pattern you could use to load that data then. I would be remiss not to talk about SSIS. So to be clear, we can use SSIS to load your data warehouse. Now, SSIS is not available as a cloud service. So to use SSIS, you're going to need either an on-prem instance or a VM running SQL Server to use SSIS, but you can use it. One important thing to know is that when you're using SSIS to connect to your data warehouse, is that it only connects to the single control node. And in doing so, it cannot take advantage of the parallel processing operations. So again, SSIS works for loading your data warehouse. It's just that it does not take advantage of the processing power of the warehouse in the way that querying does. So now if you're loading just modest amounts of data with your ETL, using SSIS still works pretty well. But then you'll only be getting the benefit of the of the Azure Data Warehouse when you're doing your querying or your aggregation, and not when you're loading it. So at a high level, here are some use cases of when I might want to use Azure SQL Database and when I might want to use the data warehouse. So at its most basic, the database is really designed for high transaction volume. So we saw that with the connection limits and the low connection limits for the data warehouse, and the high session limits for the database. The Azure database could be used for operational reporting, whereas the data warehouse really is designed for doing reporting and aggregation and trending across large sets of data and doing historical analysis and that kind of thing. If your database is consumed by a large user base, certainly the Azure SQL database is going to be a better fit for you there. The Azure Data Warehouse is really designed for a smaller user base. So think back again to the connection limits. It's not really, the data warehouse is not really designed to be used by hundreds and hundreds of people all running an application at the same time. Microsoft has a kind of a guideline of when you might want to start looking at the data warehouse for performance gain. So if you've got a data warehouse that's, say, 250 gigs or less, you can still run the data warehouse inside the database, and that's going to work really well. You're not going to be getting much of the benefit of the capability of the data warehouse until you're over that 250 gig threshold. And that's just a guideline. That, of course, would depend on the style of your data and et cetera. How many tables you have and things like that. But that's kind of a guideline if you're kind of wondering, well, how do I know when's a good time to move up to the data warehouse? That 250 is where you might start saying, hey, I could probably get some benefit here from moving up. And then the other thing that I talked about was the fact tables with 60 million records. And that 60 million, again, is a number that allows us to take full advantage of the clustered column store index technology. If I've got tables with fewer than 60 million records, I cannot take full advantage of that. And so those are some use cases for how I might decide to use one platform over the other. So in summary, I mean, can I run a data warehouse on the Azure SQL database? Absolutely, you definitely can. It's just, as data practitioners, we understand a data warehouse is really just a set of tables that are organized in a certain way to facilitate analytics and reporting. So can you use the database? Absolutely. Asked another way, do I need the data warehouse to run a data warehouse workload? And the answer is no, you don't need it. But if you're looking for really, really great performance on really large volumes of data, it's definitely worth looking into. Asking the opposite question, can I run an OLTP or an application database on the Azure SQL DW? I mean, technically you can. It's a database. We saw it has some of the limitations with feature functionality, et cetera, but in the end, it is a relational database. So, I mean, there's no reason you couldn't, but generally speaking, it's really not going to perform that well on, what we call singleton queries or small volume or high volume transactions, each that are referencing a small amount of data. It just won't perform all that well at all. So technically, yes, you could, but definitely not recommended. Erica, that was all I had to cover today. I am available to answer any questions people may have.
Okay, let me go ahead and take questions if anyone has any, and please go ahead and type it up in the chat. Let me read some out to you, Bob. Is compression available in blob storage for DW storage, and how does it affect, I lost it here. And how does it affect the price per TB?
So we don't really have any control over how the data is stored. On the compression, you don't have the like page level compression that we have in the database. So the best case there would be if you can get into using the clustered column store, and that does store everything in that column store index, which is essentially compressed. But no, we don't have the option to do the compression like we do with the database.
Okay. Hector says we have APS/PDW on premise. Should we move to Azure DW directly if we want to move to the cloud?
That's a great question. I don't think that we can just do a straight lift and shift, but I think that this would be a good candidate for Polybase. So a pattern there would be to take your data out of your on-premise APS PDW, load it into blob storage, and then use that create table as to load that data into the data warehouse. So could you do it? Yeah, for sure. I'd be just curious to understand why or what benefit they're looking to gain, but could it be done? Yes.
All right. Tony asks, if we already have a star schema warehouse, are there tools that will help us migrate to Azure DW?
There are, unfortunately, I don't have any information on them at this point. I've not used those. I believe that there is a migration assistant, but I have not tried that, to be honest. I'll take that as a follow-up and look into that.
All right. Andy asks, if you start an Azure SQL database, can you port over the data to DW once you reach the 250 gigabyte limit?
Yeah, I think that the best approach there would be to do what I talked about a second ago with the APS example, would be to take the data out of the database and put it into blob storage. That can be done with a number of techniques, SSIS included. And then once you have that data in blob storage, to load it into your data warehouse. So there are a couple different ways to get the data out of the database and into the data warehouse, but it's not just like a backup and restore that we think of in the on-premise terms.
All right. Keith asks, what is the preferred method of loading data into an Azure data warehouse?
That is a great question. That is a topic that could be a webinar or a training class on its own. The preferred word depends what you prefer. Microsoft recommends using Polybase purely for performance. So if you have a large amount of data that's continuously being loaded into your data warehouse, anytime you can use Polybase and take advantage of the parallel processing, that is going to help you. But on the other hand, if you're already using, let's just say SSIS to load a data warehouse, and you just want to switch from using a database to loading the data warehouse, your preference might be to try to just tweak your SSIS and load the data or transform the data such that it can be loaded into the Azure data warehouse. I've used SSIS to do that, and it works, but to be clear, it's not the fastest if you're talking about loading large volumes of data.
All right, thank you. Is there a roadmap item to define foreign keys as no check only? This would still be helpful metadata for BI tools, etc. So is there a roadmap item to define foreign keys as no check only?
I don't know for certain, but my hunch would be no. And so it's something, I don't know that I listed it on the unsupported features, but we don't have check constraints and we don't have foreign key constraints. The whole thing with the foreign key constraints or the lack thereof is a really interesting topic. Part of it is that that's just left over from the predecessor product that this came from, but there are also other massive parallel processing vendors and platforms out there. And generally speaking, those platforms also do not support foreign keys. And part of the discussion that people have with the foreign keys in the data warehouse is, well, if you have a well-managed ETL and you understand your data, that you should know that any key value that's used in your fact table exists in your dimension, and therefore there's really no need for foreign key. But to answer the question, is it on the roadmap? I don't believe that it is, and that's, I completely understand the question. It would be nice because diagramming tools can use that and understand relationships, et cetera, but it's just not there with the warehouse.
Okay. How does Data Factory work for these two options?
So the two options, I'm trying to think if that's just data warehouse. So Data Factory ultimately is going to be just executing generally Data Factory is used for like executing SQL or for moving data around in the cloud. And so to the extent that you can use Data Factory to load your data into blob storage, if you're pulling from another, particularly if you're pulling your data from another cloud source, we can use Data Factory to move that perhaps into blob storage, and then have Data Factory execute SQL or store procedures on your warehouse to then consume that data using Polybase. So that's one pattern for using Data Factory on those two platforms.
Okay. Have you done a side-by-side comparison of Azure Database and Azure Data Warehouse? What were the results?
I have not. I'm trying to think of the best way to. I mean, no. The short answer is no. But generally speaking, I guess in my experience, it's been kind of the decision to go with the warehouse if we feel like that was the best way to go, rather than kind of building both and then picking one or the other based on performance. That was kind of a decision that was made generally in our projects, that decision would be made to go with one or the other, as opposed to running both and choosing. So no, I have not tried that.
All right. If we have a lot of SSIS load packages into our data warehouse, can we use SSIS to load Azure Data Warehouse and use Polybase together for large data items?
That is a complicated question, and I think that the short answer is yes. So Polybase, what I've done with Polybase and SSIS is that you can write queries. So let's just say you had a query that loaded a fact table. You can use a query that uses, or write a query that uses Polybase, connecting out to blob storage, but execute that query via SSIS. So SSIS is just executing a store procedure or a query just like it would any other query, but under the covers, what the query is doing is reaching into blob storage using Polybase to load your data. So the answer would be yes, you can do that.
All right. Would HD Insight be better than using SQL Data Warehouse for analytical solutions?
That's a great question. And one thing I should have emphasized more at the beginning is that HD Insight is what we call a schema on read. It's not a relational database. So you can, sure, yeah, if you HD Insight and is great for doing that, but it's not going to have the full database support that the data warehouse would. And I think that's really the big difference there. So can you use it? Definitely, yeah. But with you're talking about dimensional modeling and things like that, and then everything with the backups and the redundant storage, et cetera. That's kind of the difference there in the warehouse.
All right. I'm going to take a few more questions here. John just wanted some confirmation. He said, did you say clustered column store index is the only support in Azure SQL Data Warehouse?
No, I don't. If I said that was a mistake. No, the clustered column store index is one of 3 storage methods that's available for storing your data, and the clustered column store index is not unique to the data warehouse. It's available in SQL Server as well.
All right, one last question. This one is a more general question. Is SQL database or data warehouse enabled to be accessed from Power BI?
Both, absolutely, yes. Power BI. I mean, it's just a connecting to a database. Yes, both can be accessed with Power BI. A bit of caution on the data warehouse side. It's generally not recommended to use Power BI and the data warehouse in the direct query mode. And the reason is really speed, which sounds kind of funny, but the data warehouse is querying generally vast volumes of data. So one of the things that they say is a query that might have formerly taken hours will now run in minutes, and a query that ran in minutes will now run in seconds. Well, if you're talking about a dashboard or a responsive chart in Power BI, we're not talking about minutes and seconds. We're talking about fractions of seconds. So therefore, using the data warehouse with the live connection to Power BI is really, I mean, you can do it, but it's not recommended because it's just going to make the experience of Power BI really quite poor. But can you connect to it? Absolutely.
All right, well, it's a little past noon. I'm sorry for keeping everyone a little late, but I know sometimes we run a little over time with the questions. Thank you so much, Bob, for presenting, and thank you everyone for joining our free webinar today. As always, we do record all of our sessions, and we will be sending all registrants a follow-up email, including a link to that recording. We constantly get questions about, can I see this webinar again? So yes, you will be able to access a recording where you will see the entire presentation. You can also find the recording on our website at pragmaticworks.com. So thanks again for your time, and we look forward to seeing you all next Tuesday for another free training session. Thanks again, Bob. Take care.
Thanks, Erica. Take care.